This is Shakil Ahmed. In this tutorial, we will discuss about k-nearest neighborhood method. This is a simple non-parametric machine learning algorithm that can be used for classification as well as regression problems. It just works like creating cluster based on k-nearest neighbors of each dataset by pre-specifying a number of neighborhoods, okay, and storing the data and uh, basically it when a new observation comes, it just uh, find a distance from the rest of the data points and then assign to the nearest neighborhood where the distance is minimum. So it work just like um, making different nearest neighbors based on distance matrix, a gradient distance between the features, and then works just uh, make a prediction if the independent variable is a quantitative variable and uh, classify using the mode when the dependent variable is qualitative. So we will discuss a data set of chronic heart disease. The outcome variable is chronic heart disease status, and we have a lot of predictors. This data is from Framingham Heart Study dataset. I have downloaded it from Kaggle. Here is the link, and I will upload the data here on Google Colab. It's in my download file, and then I will open it, and then we can just import the data. Still, uh, it has been uploaded, and now it is working. You can just see the data set. And then if you want to see the distribution of data, you can see the all suggested graphics for the data set. Here we can see most of the variables are on a quantitative scale and some of the variables are on qualitative scale. So we can do all these. Now we need to import relevant packages for running the k-nearest neighborhood in our uh, Python Google Colab. We import the k-neighbors classifier, just random forest, just like random forest classifier. We can import k-neighbors classifier and uh, cross value score. This is basically used to find the best value of the number of neighborhoods. Okay, and then we also import numpy as np, and we also import matplot library, and then from sklearn matrix we import all these things. uh, Accuracy score, confusion matrix, classification report, and ROC curve and AUC. We will run this. All the packages are now imported. Now we can pre-process the data. We can drop DNA values, and we can drop the variable y from the x list of the x variables, a data frame consisting only x variables, and we just extract the y variable alone. And this is our x y data sets. And then we split the data into test and training based on 20% test and rest of the 80% in training. Uh, for that, we need to import sklearn model selection. From this library, we import train test separate package, and then we can run this. So now our data is separated into test and training. We have xtrain, xtest, ytrain, and ytest. And then we need to standardize the data the to make the data on a 0 1 scale or on in terms of zero mean and very standardized scale. So you can do using we need to import standard scalar and then scalar standard scalar, and then we use the input xtrain and xtest. So we can do this just, and then parameter selection, we need to find the best value of k among the all the available values. So for this purpose, we perform a cross validation analysis. Cross validation means we keep some data set as training and keep some other as test, and then we see which value of k performs best or provide best prediction error or perform best accuracy, lowest prediction error, and that value will be considered for the analysis. So you need to do this before finalizing your final model. So how we can do this? We set a k possible values of k in the range of 1 to 31. I said you can, for example, set 1 to 30. I think 30 is also okay. Then k value score. This is a list, and then we run the loop k in k values, and then we run a k nearest neighborhoods, and n neighbors is equal to k, means we are selecting the uh, k neighbors from the k neighborhood classifier, and then score cross validation score, that is the knn, the model we run, and the X training, Y training, and cross validation is equal to 5, means it's also a k-fold cross validation where we are we are dividing the data into 5 equal parts. And then score as accuracy. And then we see the cross validation scores, the mean score for all the uh, for all the possible range of k. You will see the cross validation scores, and then we will plot and see which how the cross validation score we can see based on the accuracy beyond see. We can just plot the accuracy versus the number of class, and we decide the number of class which provides the best accuracy. So let's see. Then to plot this, we have again PLT figure, the figure size, and the K values. We are plotting the K values and CV score. CV score is basically the accuracy. And this is the label, number of K neighbors, and the Y labels, and then a title, and then the ticks, x-axis ticks, and then plot grid. See, this is the plot, and number of neighbors 1 2 3. This is the possible values of k in the range of 1 to 31. So we should exclude 31 to include the 30 in the dataset. But if you see, the accuracy is increasing with increase in k, but after the value of 19 almost it's going stable. But if we say that if we keep them the number 12 or even 14, after that it's uh, stopped increasing. So we can see the best possible value of k from the which provides the best cross validation score. So which is at 25, I think, in this data set. We can see a 25 or 19. So we can find this the k values and then the maximum of the cross validation score. The value of k which provides the maximum cross validation score and then print it. So it's 20, it's 14. You can see the 14 is giving largest the largest accuracy for the k value 14. And then KNN best. Now we will run the nearest neighborhood for k is equal to 14, and then we can predict the values. We will first KNN best. We create a classifier, and then we need to set the number of neighbors while creating a classifier, and then for this classifier we are fitting a model with X train and Y train. You can see the model, and then we can predict the y values again, knn best dot predict and then x test and scale. So all the values are predicted mostly as non-chronic heart disease. Only a few cases are predicted as chronic heart disease. And then we can find the final accuracy, which is 0.85. We can also see this value here, 0.85, or it's just near to 0.85 if we see for 14 for class relation. So now we can find the confusion matrix. The confusion matrix tells the predicted the actual values and then predicted values. Only 4 cases are predicted accurately, which has chronic heart disease, and out of and 619 values are predicted as non-CHD. And we can also find the classification report for Y test and Y predict. This provide the a precision recall for the two classes, first score, and then this supports. This is the actual number in the two classes we have in the data set. So then these are the averages for these two values and the weighted averages. We can run this, which we have already run. Then we can also find the predicted probabilities for each individual. The probability of having a chronic disease, we can just check the actual probability. Basically, these are the predicted values, but we can check this individual has almost, for example, 60% chance of having a chronic disease or less than 50% chance. So basically, when we are predicting, we are just saying that if the probability is 50 or above, then we are categorizing it as a disease, and if the probability of prediction is less than 0.5, we categorize it as 0. So we can see the predicted probabilities. Just predict dash underscore probe and then x test scale, and here 1. So then we can find the false positive rate, true positive rate, and then threshold, and we can find the ROC curve. So ROC curve basically for all possible thresholds, it just make a curve between false positive and true positive, false positive rate on x-axis and true positive rate on y-axis. So this is the command of the plot for our curve, uh, X, Y, and then color, and then label. This is the line width, and then you need to draw a straight line from 0 on 45-degree line, 0 to 1. You are keeping both X and Y a vector of 0 and 1, and then you can give a specific color, and then the line style is this, and uh, you can write the maximum limits of the minimum and maximums of the x limit, x-axis and y-axis, and then you can give the titles to the x axis, y-axis, and then the title for overall plot. So you can see this is the operating characteristic curve, or receiver operating characteristic curve, which tells the area below the curve should be large. If the curve just touches these axes, then it's a best prediction. So, and you can see if the line is close to this 45-degree line, then it means it's a rough guessing, not a proper prediction. It means your predictors are not good at predicting the, or your algorithm is not good at predicting the outcomes, non-sampled outcomes, test values in the test set. And then from matplot library colors, import list color. You can just make a scatter plot to explain uh, the process of explain the process of nearest neighborhood. Just for two features, uh, we are taking just age and feature 1 index, and feature 2 index means we are selecting the only two features. The first feature is age, and the second feature is systolic blood pressure, and we are creating two color vectors consisting two color different colors. One the bold color, and the other is the light color. The bold color is used for the actual values, and the light color basically used for the clusters or the neighborhoods, where we are when one observation falls in that region, we declare that region as the in that category. So this has also two categories, and this has also two categories. You can just check, uh, just copy this and paste on Google, and you will get the uh, color name there. So we can just run this, and then we will run a Canon for visualization. Again, we created a classifier, and then Canon visualize dot fit x plot and y plot, and then x minimum, x maximum. These are the maximum and minimum values in the plot, and similarly we can do y minimum, x y maximum. These are the limits on x-axis. These for uh, another variable, we have basically two variables, so we need to create the minimum and maximum values, and then x y y np mesh grid. So np arrange x minimum to x maximum, and this is the value, and similarly np arrange y minimum, y maximum, and np arrange. So you can just the z-axis is the predicted visualization, that is np. We basically need to first draw a scatter plot for the actual values for uh, age and systolic blood pressure, and we will get the scatter plots, and then we need to make the colors using the neighborhood methods, that is using the prediction command, and then we can reshape, put the result into a color plot. We can do a color plot, PLT figure size. We can just reshape uh, Z according to XX shape, according to the size of the X, and then we can create the figure size, and then we have three axes: X axis, Y axis, and Z axis. And the C map is a C map light. This is just background color of the plot. So whenever it includes two colors, if one color for the uh, one class, and the other color is for the uh, one neighborhood, and the other class is for the another neighborhood. So if any data falls in one neighborhood, we categorize that neighborhood as the non-CHD, and in the another neighborhood we categorize that data point as CHD, chronic heart disease. So plot also the training data points. We are plotting the training data points, and the other we can plot the X limit, Y limit, and X title, Y title, and then we can run this command. You will see. So this is our data points. We have age and systolic blood pressure. These are all original data. The light colors are basically the these are the darker colors, darker blue and pink, or you can say red, are the CHD and non-CHD. And then these two regions, the green and the pink region, shows the non-CHD CHD and non-CHD. So if any data point falls in the uh, green color, it is predicted as, for example, here you can see these are correct predictions. These are in the green color, and falls in the green color. So this is correct prediction, but this is incorrect prediction. This is non-CHD cases, but predicted as CHD. So you can see, this is just in terms of visualization for two variables per, but for more than two variables we can't visualize in this case in this way. So thank you for watching, and keep giving comment if you have any question.